to Shedland. So today I'm going to make the crank pin, and what I've got here is a piece of 5/8 cold rolled steel, which I believe to be 12L14 leaded free machining steel, just because of the way it cuts. And it's straightforward enough part, as you can see from the drawing, but it does have some tight tolerance requirements because it is a press fit into the crank webs, and then it has to have a close running fit on the journal. So we've got it stuck out a bit over 2 inches here, so that I can make the entire part in one chucking operation, just to keep concentricity on everything. Not that it's not possible to turn it around and clock it back in, but this is a reasonable approach. But since it is stuck out a ways, I think what I'm going to do is face off the end and put a center hole in and give it some support, because I do want to maintain concentricity along its length. So that's how I'm going to start. And then I think what I'm going to do is turn the journal diameter before I take any material off for the press fit pins, and just to give it the maximum support while I turn the journal, and then I think I'll do the ends, and then I'll part it off, and we'll see how that goes. Alright. Okay, I've just changed over to this tool, which gives me a little bit more clearance getting in here so that I can keep the live center in place. So I'm just going to take a very light cut across the surface so that I can establish a diameter, and then measure that, and then I'll set up my DRO. Right. Oh yeah, that's alright. So now I can take a measurement here and see if this matches the 0.38 that was on the readout. .3795. But what I am going to correct for that. So I'm going to move into the 3/8 position and correct that. Now I can attempt to hit final dimension. You see that? .376, well, 0.3759. So Anytime you can hit a dimension within a tenth, I think you're doing alright with that. So the next stage then is to make the journal. So I'm going to do that with a grooving tool. And this is the tool that I'm going to use. It's a nice stout grooving tool. So now I have to re-establish my position. There's a couple of ways of doing this. One is to bring the tool over like this, to touch on this face, and then zero it and move in the thickness of that cutting tool. And if I look at the tolerance on the drawing, we're at plus or minus 10 for the width of the shoulder, so that is the technique I'm going to use. So Z0. So now I can come in and move to minus 80. There we are. That's my new Z0. Now I know the edge of that tool is in line with that shoulder. So I'm going to come in 0.14. I'm going to take the bulk of the material away and then come back and do finishing cuts. I'm enjoying using the coolant. Now I've repositioned the camera, see if I can show what's going on better. So what I'm doing is just taking plunge cuts to clear out the bulk of the material, and then I'll do as I did before. I'll take a measurement of what I've got and match it up to the position of the tool so that I can accurately cut that journal. Okay, so I've measured this diameter, it's 0.5483. .5144 on the readout, 0.5145 on the micrometer, so good enough. See what we got. 0.4992. So that's alright. I've still got 20 thou to take out of each of these shoulders. And I'm going to do that now, and then I will go in an extra 5/10 and polish up that surface some more. It's nerve-wracking, actually. So we'll now go to the 120 position here. Now let's see what we got. .4985, perfect, right in the middle of the tolerance zone. Wonder how we're doing on width. .558. 560 plus or minus 5. So we are on again. Okay, so now to move on to the next pin. So we need to come over to the 800 position, and I'm going to do the same thing. I have to plunge in and get to 376 on the next pin. Coolant. .3762. So we are there. Well done. So there we are. We've got the pin this end, we've got the journal, we've got our webs. So all that's left now is to break these corners, put an undercut in these corners, which I'm going to do using a thinner grooving tool, and then I have to put a lead in. And the lead-ins I will do after I've parted the component off. Good. Everything here went very well. Perfect, so that's a little undercut both ends, and that will prevent any small radius in that corner from properly seating this when I press it in place. Alright, and now I'm going to put coolant back on, because I've found that parting off on steel just seems a little easier with some coolant. Go. Okay, so not too much left to do now. I'm basically going to turn the pins down to length, break these corners. I actually want to put a bit more undercut in here. So I've put a 3/8 inch collet in place, got this secured, so I'll work on this end, turn it round, and then do the other end. The length of the pins is plus or minus 10, so that's very easy. I'm just going to touch that off on there, zero my Z, and then we'll get this cleaned up. Just little undercuts in there just to make sure that there's nothing to hold the webs off of the shoulders here and the con rod off of the journal there. I think the reason a lot of people, and myself especially, run into problems when they first assemble model engines is because they forget that there are these radii that exist, and when you first bolt things together they jam up and you don't know why, and then you have to run them in. Well, my goal is to not have to run this engine in, so that's why I'm taking this trouble. Now, there will also be a lead-in put on here. And I've got the tool post nice and square at the moment. There, see how well that sits up against the collet face, which is why it's actually running very true. But these operations, finishing these ends and putting in these undercuts and things, are not critical to the geometry. It was important that that surface and the two pins were turned in the same operation so that they are very concentric. I don't know if you can see that on the camera, but there is actually run out. This is not perfectly true in the collet. That's okay. That's not okay. Dumbass novice mistake there. Improperly supporting the part. I think we're okay now. Do this a different way. As far as I can tell, the little mishap there hasn't troubled the part beyond a few marks, which can polish out. I believe, I don't think it bent the part. The part luckily is stout enough. But I'm going to get the carriage out of the way and aim the camera. There we are. We'll do a little bit of polishing. Yeah, I think that's okay. So the rookie mistake was thinking that this little stub was enough to support the part in the collet, and it isn't. See, I can undo that. With these collets you have to have some amount of length throughout the collet body, otherwise it simply pinches and holds like this. But I'm pretty sure that everything's okay. Anyway, I'm going to go and take this, put it on a pair of V-blocks and see how it looks. Okay, here we are at the granite slab at the end of the bench. So I've got a dial test indicator touching off on top of the center the journal here, and I have the part in a pair of precision V-blocks. So the idea is to gently turn this and watch the needle for run out. I have to be careful not to make it jump all over the place. See if I can do this so that you can see what's going on. Just stay flat down, but Very little movement, and that's more me pushing it around moves it more than the needle moves turning it around. So I think we're okay. I think everything is straight. The only damage to the part was on the material that got removed, and a little light chatter mark one end, so I think we're okay. Well, I wasn't going to do this, but why not? So I'm just doing a test fit of the crank pin in the connecting rod. So held loosely it turns, and where the story really starts is when you tighten up these screws, and any radii that are left that you didn't really want, or any burrs, come into play. I'm going to get on it and really tighten these down, and such things will cause it to bind. But not on my watch. Look at that, that is an as-made fit as required. And so that makes for a happy model engineer. Absolutely lovely. Well, thank you for following along. I do hope you get out to your own workshop soon, make something that you enjoy, and all the very best. Stay well. Thanks for watching. Don't touch that dial. We'll be back soon. Bye for now.